to the next question.
Yeah, I understand. This is a difficult situation for everybody.
Yeah.
So unfortunately, the machine doesn't know it.
Yes.
The machine doesn't understand what the pandemic is. It still
Yeah.
does what it has to do, and we have
Yeah.
to take care of them. So as we have limited budget, what I would suggest is we at least do the offline monitoring at the moment. So whenever you have a chance, you try to shut down your machine quickly and do the offline test. The even better thing is you at least install the partial discharge sensors. With that, you have the ability to do the PD measurements whenever you want.
Selamat pagi, Bapak Ibu semuanya, peserta webinar Tiara hari ini. Apa kabar semuanya, Bapak Ibu? Semoga semuanya dalam keadaan sehat ya, terutama dalam masa pandemi COVID-19 yang belum mereda, terutama di Indonesia. Semoga kita dalam keadaan sehat, tetap semangat dalam menjalani aktivitas kita, pekerjaan kita, dan semua kegiatan yang kita lakukan. Amin. Baik, Bapak Ibu, terima kasih sudah bergabung dalam webinar kami pagi ini. Pagi ini kita akan berdiskusi, membahas mengenai topik Partial Discharge, dan kita melakukan WFH ya, Webinar from Home. Jadi kelihatan dari background saya lagi di rumah, Bapak Ibu. Karena di Jakarta masih diperpanjang PPKM-nya. Oke. Dan hari ini kita mengundang salah satu prinsipal Tiara, yaitu Mr. Rajendra Nutaki dari Quarstek, Regional Manager dari Quarstek atau Quarstek ya. Hello, Mr. Rajendra. How are you? We cannot still hear your voice. Mbak Safira, kedengaran suara Mr. Rajendra?
Are you able to hear me?
Oh yeah, okay. It's good. It's good now. Perfect, yeah. How are you, Mr. Rajendra?
I'm very fine. Yeah, working from home.
Yeah, same.
Life nowadays.
Yeah, same. What's going on in Malaysia related to COVID-19 currently?
It's getting better, not with the cases, but with the vaccinations. So the government is driving quite well now. They're targeting to vaccine all the public by the end of October, which is good. Yeah.
Yeah. Hopefully we can get the all this condition better.
Yeah.
And so we can do our all activity normal again. Yeah.
That's right. I'm missing Indonesia as well. The traveling there, Jakarta. I miss all the fun.
Yeah. Okay. Thank you. Thank you for welcome on board to our webinar. I think this is your first time, right, with us?
Yeah, that's right. First webinar with Tiara.
Okay, let me say hello again to our participant, and after that I will give it to you because this is your show to our customer in Indonesia. Oke, Bapak Ibu, itu tadi Mr. Rajendra yang akan membawakan materi partial discharge pada rotating mesin. Kali ini kita akan membahas apa itu partial discharge, kemudian kenapa sih kita penting melakukan monitoring partial discharge pada critical asset kita. Kemudian apa saja penyebab munculnya partial discharge, dan tentu saja mengapa kita perlu investasi teknologi dalam memonitoring partial discharge ini. Kemudian nanti juga Mr. Rajendra akan menyampaikan mengenai teknologi partial discharge baik offline maupun online monitoring. Kemudian ada semacam study case atau contoh pola partial discharge yang menunjukkan kegagalan pada critical equipment kita. Nah, mungkin nanti sambil webinar berjalan, Bapak Ibu bisa langsung mengajukan pertanyaan di Q&A. Kemudian nanti beberapa pertanyaan juga akan kita bahas di akhir sesi presentasi. Nanti ada sesi tanya jawab. Mungkin presentasi sekitar 45 menit sampai dengan 1 jam. Kemudian kita akan buka sesi membahas Q&A. Tapi sambil berjalan, Bapak Ibu bisa menyampaikan pertanyaannya di kolom Q&A. Oke, demikian Bapak Ibu. Saya akan melanjutkan ke Mr. Rajendra. Rajendra?
Yeah.
Yeah, time now.
Right. Thanks a lot, 𝗥𝗍𝗶𝗹, for arranging this webinar and having me here. For all the guests who joined the webinar, I hope you're all safe from the pandemic and received 2 jabs of vaccine. So let us get into the topic straight away. Let me share my presentation. Just bear with me for a couple of seconds. I hope you're able to see my screen.
Yes, Rajendra, perfect.
Perfect. Let me turn off my video for a while, and once I finish the presentation, I can turn it on for the interaction with the guests, right?
Okay, of course, yeah.
Good morning and welcome everyone to this webinar from 𝗥𝗍𝗶𝗹. My name is Rajendra 𝗥𝗍𝗶𝗵 and I am the presenter of this webinar today, the topic of partial discharge on rotating machines. Today I will be sharing with you some of my knowledge obtained in many years working as a service engineer for the 𝗥𝗍𝗶𝗵 group. Also, you can ask your questions in the questions section and we will try to answer as many as we can. Before we get into today's webinar topic, a few words about 𝗥𝗍𝗶𝗵. 𝗥𝗍𝗶𝗵 is a member of 𝗥𝗍𝗶 group of companies. They are located in Rundlos, Switzerland, but present worldwide. 𝗥𝗍𝗶𝗵 was founded in 2011. Our focus is mainly on rotating machines monitoring systems. We deal with a variety of offline and online monitoring applications and specialize in development and manufacture of condition monitoring systems for both hazardous and safe area locations. Our strength is what we benefit from industry-leading expertise drawn from 100+ years heritage. We provide services worldwide through 𝗥𝗍𝗶𝗵 offices, and where we do not have office, we support our customers by our tech partners as we have Tiara in Indonesia. LIFEVIEW is a registered trademark of 𝗥𝗍𝗶𝗵 for condition monitoring. Here is a slide which shows the overview of some of the main products we deal with. Our aim is to provide complete solution for the rotating machines, which includes partial discharge, shaft voltage, and air gap flux monitoring. And when it comes to offline, we have solutions for tan delta and partial discharge, which can work both on 50 Hz and 0.1 Hz. These are the contents we will be speaking about in today's presentation. We start our presentation by discussing the importance of condition monitoring solutions, where we also see some of the failure statistics. Then we give you introduction to partial discharge and its properties in rotating machines. We will also discuss about the causes of the partial discharge, and we give you a brief overview on the technical solutions and the methods for measuring the partial discharge. We will also speak about the differences between online and offline monitoring, and also different ways to measure the partial discharge. In the last, we will speak about the selection of PD sensors for the rotating machines. Let's get into the topic straight. I believe many of you have joined from maintenance department, and these are the questions often asked by your superiors and management. How can we increase the reliability of the machine or increase the life of the machine? How can we run the machine without the failures? Yeah, and the answer is to receive alerts to the problems before the fault occurs. And how the safety increases? It's the same as above. You always have to receive the alerts to the problems before the fault occurs. This is a slide we can correlate with our daily lives. If you're an athlete, how would you prefer to check the pulse of your body? Would you still prefer the age-old technique by placing the fingers on your neck and measure the pulse? Or would you prefer the modern methods like health tracking systems, which shows you heartbeat, number of steps you walked, sleep cycles, and whatnot? Frankly, this is how the condition monitoring techniques has also evolved in the modern days. Rest market.
Apologies for this.
Rest market drives mainly on aging infrastructure, rising costs to replace equipment, longer lead times for new equipment, increased pressure to operate 24/7. Here are some of the benefits of using monitoring diagnostics. You can always avoid unplanned outages by having the alerts before the faults, lower the maintenance costs, before the capital expenses by extending the asset life, and enables better decision making for the maintenance team. Most of the machines are equipped with simple accelerometers and some vibration sensors. The question is, are these enough to monitor your machine healthiness to avoid catastrophic failures? Let us find out. We have some of the statistics to add weightage to what we are saying. This is a research carried by Allianz Insurance Company based in Germany. I think it's between 1996 and 99. When you consider all the parts of generator or motor, you can see how important the monitoring of stator winding insulation is. The percentage of failures on the stator winding is 63% when you compare it to other parts, which are also critical, but the failure percentage is less than 12%. This is another interesting study which published in 1990 and explains the failures in aging installations. So we have graphic representation of different types of failures, bearing, vibration, environment, and insulation aging. So if you consider 0 to 5 years, insulation failures are very little. But when you move to 11 to 20 years, you can see the percentage of insulation failures increases to 23.5%. I hope the slides we showed you have convinced on how important the monitoring your assets is. Just to add one more point to it, all high voltage machines will experience partial discharge, even from new. Discharge levels are low when the machines are new, but the levels increase over the time, which will eventually cause failures. Can we afford these consequences? Of course not. Let us now discuss more on partial discharge and its characteristics on rotating machines. What is partial discharge? A partial discharge is an electrical discharge that partially bridges the gap between the conductor and earth, or it can also be happening between the layers of insulation or the insulation in the conductor. Technically, it can happen anywhere where there's a junction between two electrical components. Partial discharge always happens between these two junctions, not completely bridging the gap, but occurring at some point between them. So what are the conditions for PD? When a potential difference builds across an air-filled void due to the capacitive voltage divider, PD occurs if E is greater than 3 kV/mm. That is, the electrical stress exceeds the electrical breakdown strength of gas. The larger the void, the larger the discharge is. How do we study PD phenomenon? We study partial discharge by phenomena called phase-resolved PD patterns, normally known as PRPD patterns. In the PRPD, we save all the information of thousands of pulses recorded for each second, and we plot them correlating to the phase angle. In the picture, you can see the modern way to visualize the partial discharge, where vertical axis indicates the PD pulse amplitude and horizontal axis represents the phase angle. We use the following PD test standards: IEC 60034-27 online partial discharge measurements on the stator winding insulation of rotating machines. Next one is IEEE 1434, which is a guide for the measurement of partial discharge in AC electric machinery. We now move to the next section, which is very interesting, the causes of partial discharges. We come across customers who always ask if their machine has partial discharge. We say it is better not to argue with physics. As we have seen in earlier slides, every machine with voltage above 3 to 4 kV might suffer from partial discharges. So what causes partial discharge? Here is the introduction to team stresses: thermal, electrical, ambient, mechanical. Together, we call them as team. The main cause of the partial discharge on rotating machine is team stresses. Team means thermal, electrical, ambient, and mechanical stresses. We will go into each of the team stresses in detail in the coming slides. The result of each of these causes is partial discharge. In general, effects we can identify by monitoring partial discharge on rotating machines is loose wedges, bar vibrations, slot discharges, broken conductors, end winding contamination, discharges between phases, delamination of the main insulation. Thermal degradations. These are one of the most common aging mechanisms. Studies state thermal stress result in relatively slow insulation degradations. So what are the reasons for these thermal degradations? The reasons are operation losses, examples, start and stops of the machine, changes in the load, circulating eddy currents, sometimes the board cooling design itself. Interestingly, Every 10 degrees increase in the temperature decreases the remaining life by 50%. As you all know, stator winding insulation is made of different materials, and different materials have different expansion characteristics. So what happens during the load cycling? Due to these different thermal expansions, loss of bonding between the conductors and insulation happens. This will eventually create voids and then PD. Traditional way to measure winding temperatures are by RTDs and thermocouples. Actually, these sensors show lower temperature up to 5 to 20 degrees than actual copper temperature. Therefore, are these sensors good enough to alert thermal changes in your machine? We have to question ourselves. Having a PD monitoring system on your machine gives you a better visibility of what exactly happening with your stator windings. Now we'll discuss a bit on electrical stresses. Operating voltage primarily ages the main insulation, but it's a very slow degradation mechanism by itself. Electrical engineers in this webinar can instantly understand this picture: transient, subtransient, and steady-state envelopes. These transients can create new PD defects that will not extinguish after being created. Winding contamination plays a major role in the ambient stresses. These create tracking across the spaces between the coils of different phases. This also degrades the mechanical supports and surface insulation. Contamination together with moisture creates a surface tracking which can contribute to insulation failures. Sometimes improper ventilation and heating speeds up these problems. The effect of ambient stresses on the winding is typically a long-term aging process. This will be ranging from months to years. This slide shows you a very good example of the effect of ambient stresses on the windings. We have conducted 2 times partial discharge test on the same machine. On the left, before cleaning, that is, the winding is with oil and dirt contamination. On the right, test has been carried out after the cleaning, that is, after the cryogenic cleaning of the windings. So clearly, on the right, we can see the amplitude of PD has decreased quite a bit. This shows the more the contamination on the winding, the more the PD is. Mechanical forces or mechanical stresses. This is the most important member of team forces. In general, the vibration forces increase with the operating currents, which will eventually lead to the increase in insulation abrasion, winding settling, looseness in the wedges, and end-arm support weakness. Mechanical forces are the main causes of slot discharges, end winding strands, and turn cracks. These will lead to relatively quick failures when compared to other forces. This picture shows typical generator open circuit condition. Here we have a generator rotor, stator windings, the air gap between the generator rotor and the stator. And this is the direction of the magnetic flux. Most damaging PD occurs when an air gap exists between the stator core and the side of the stator windings. You might remember that when a current flows through a simple wire, a magnetic flux is being created around that wire. The same happens when the current flows through the stator winding. And over a time, the semiconductor layer can be damaged, triggering partial discharge. This can eventually lead to the main board breakdown as well. Now we'll discuss the effect of resonant frequencies on the machines. That is 100 Hz for the 50 Hz network and 120 Hz the 60 Hz network. These are the main forcing frequencies for two-pole generator and windings. Your generator becomes some degree of oval because of these forces. Unfortunately, remember, the two generators, even though manufactured as identical, might still behave uniquely with different natural frequencies. Also, it is worth noting that the natural frequency values depend on the change of temperature. Resonant vibration such as this has been a cause of major failures in the past, resulting in significant downtime ranging from weeks to number of months, with obvious implication in the terms of cost, generator availability, and revenue loss. End result of these forces on your machine is what you see in the picture on the left. Just imagine the combined mechanical forces happening on the machine winding, and the winding is vibrating against the rough surfaces. That's right. The impact of these forces is quite severe. It's like thousands of sharp knives constantly damaging your insulation. Team forces kill your machine every day. It's not too late for these generators to give life again. Start monitoring and avoid these failures. There are a few other factors other than teams which could cause partial discharge on your machines. Those are badly designed windings, clogged coolers, poor winding quality itself, and global VPI technology. This picture shows a typical slot section indicating different locations of the PD. By now, I hope you already have an understanding on the main causes of the partial discharge. Team forces result in variety of partial discharge phenomena. Some of them are internal discharges in the voids and cavities, surface discharges along the interfaces of different materials, corona, visible discharges on the highly stressed electrodes, spark to conducting components under floating potential. Partial discharge is a very fast transient pulse, and this can be measured by various techniques. Some of them are electromagnetic pulse, light emission, ultrasound wave, and electrochemical reactions, which is also called as ozone. Any of these can be used to measure the partial discharge. Electrical PD sensing is the most common technique, as this allows to quantify the partial discharge phenomena. Let us now get into the new chapter, selection of partial discharge sensors. Before getting into the sensors typology, let us see how to detect the signal itself. The localized insulation defects generate PD signals which are subjected to the electrical stresses. This phenomena is the source of high-frequency electromagnetic signals. The conducted signal path can be forced into the sensor and measured, while the irradiated signal is subjected to the generator design. Those can attenuate and affect the sensitivity. Different sensors produce different PD outputs, and they have different sensitivity as well. Some have the same signal and some doesn't have. Let us discuss the differences between three types of sensors: capacitive, HFCTs, and antennas. Antennas provide very high local sensitivity. But as you know, we require more of these sensors to cover a complete area. The capacitive sensors provide better sensitivity than HFCTs. When it comes to installation, antennas requires very high efforts. When it comes to safety, antennas provide the higher safety when compared to HFCTs and capacitive sensors. We have already discussed earlier that PRPD pattern needs to have a synchronization signal. The voltage signal can be correlated to the applied voltage of the signal. The signal is available with the capacitive sensors, but not available with HFCTs and antennas. Signal attenuation plays a major role in the selection of sensors and also the measurement of partial discharge signal. Measurements at lower frequencies create noise problems. The measurements at higher frequencies create attenuation problems. Our field experience indicates that using 1 to 20 MHz frequency range for measurements, additional digital processing based on the PD pulse characteristics works very well to detect the PD activity in the industrial environment. It also helps to locate a particular area with PD activity and distinguish internal PD activity from external noise. When it comes to the traditional factory testing, they use very low frequency band, it is 25 kHz to 800 kHz, because they have a controlled environment, shielded rooms with very little noise or no noise. But when it comes to the field environment, noise does exist. So devices must move on to higher frequencies to eliminate the noise. These are some of the points which you need to consider before the selection of sensors. Signal attenuations are high in the rotating machines when compared to the large transformers. The more you go, the higher frequencies, the more attenuation it is. Noise does exist. The higher frequency you go, the lower the noise floor. But the problem is, the more the higher frequencies, the more the attenuation is. Selection of right frequency band is very important by compromising between the attenuation and noise. For online continuous PD monitoring, it is required that we install PD couplers fitted permanently on the machine. Before we install anything, the first requirement is to avoid any failure risk for the equipment under monitoring. For this, we ensure each sensor is subjected to 3 times rated voltage withstand test. Also, the couplers are tested for PD free at rated voltage. The capacitance and voltage ratios are also tested with small tolerances. The very frequent question asked to us is, can we compare the offline partial discharge data with online partial discharge data? And what is the advantage of having online PD monitoring systems? So let us study some of the differences, advantages, and disadvantages of offline PD and online PD. Offline PD test is carried out usually during an outage where we can connect temporary PD capacitor coupler. We inject voltage into one of the coils and we measure 1 by 1 with PD portable instrument. These are some of the technical which you need to know for the offline test. For the offline test, the voltage stress is phase to ground and is constant along the whole winding. generator is motionless, so there is no impact of temperature and mechanical stresses. The start point, which is also called as neutral point, can be opened to do the individual phases and to compare them. The machine under test is isolated and is free from all the high frequency disturbances. One more advantage of this offline test is we can increase and decrease the input voltage and evaluate PD inception voltage and exception voltage. It is also possible to overstress the insulation with respect to the normal conditions.
Online PD monitoring on a running generator requires permanent installation of PD capacitor couplers. We can either measure the PD with the mobile or permanently installed PD data acquisition systems. For online PD tests, these are some of the technicals which you need to know. The electrical stresses in the online test is routine stress of the winding. Different load and temperature conditions affect the PD phenomenon behavior. The PD phenomena occurring in one phase can be different from the another. The measurements can be affected by the external noises. It is possible to perform PD simultaneously on all three phases. The permanent PD sensors help to correlate the machine lifetime and provide homogeneous data. Obviously, this can always be performed in a safe condition. Here is a schematic diagram for online monitoring system. So we have here 3 1 nanofarad capacitor couplers, air gap flux probe sensors, and the one which we don't have in the picture is shaft voltage brush. We call this as a PDA II monitoring system, and this is capable of measuring PD, flux probe, and shaft voltages, all connected to the one system. Once this system is connected to the internet, you can view this data from any part of the world. In this slide, you can see some of the pictures of our installations. On the right side, it is PDA II monitoring systems. And on the left, you see the 𝗥cie⁻ coupling capacitors rated for the 12 kV machines. Offline tests versus online tests. You guys have to tell me which one is the better one. So as you know, PD has become a standard diagnostic test performed on every HP machine these days. There is, however, a difference between online and offline tests. Both are valuable diagnostic tools, but only one gives you a real picture of your stator winding condition, which is an online test. Online monitoring simplifies the process of trending, makes PD results more visual compared to the offline tests. It helps to understand what is causing PD level changes in an insulation system. Online monitoring allows us to see the seasonal and other variations in the levels caused by certain dynamics such as temperatures, humidity, load, and to distinguish these changes from the maintenance effects and steady deterioration of the insulation. Online partial discharge levels are also useful indicator in determining the success and failures of the maintenance activities. Let us see some of the examples of PD. So here are some of the pictures showing the PD caused by the delaminations in the insulation. In this slide, we have a picture showing the PD caused by the inadequate spacing between the coils. Here is another PD example. It shows PD caused because of the loose coils in the slot. Let us see some of the case studies where we experienced by measuring the partial discharge data. So we have a refurbishing stator here. Before refurbishing, you can see the PD levels are different on all three phases, red, green, and white. Same Q, it applies for both QM and QAP. The values of QAP are up to 3.18 and QM are up, same up to 3.06. So after refurbishment, you can see all three values are same and they're ranging around 2 nanocoulomb. So this is a typical example which shows how PD levels can be used to judge the health of the stator. Here is another example of 480 kilowatt two-pole motor, which has been in service for only 6 years. This motor was noted as having high PD signature on V phase compared to the U and W phases when measured online. This was confirmed again by doing offline PD tests during the overhaul, and the line end shows visible PD indication due to the low end winding clearances. This was then treated with the stress grading paint at the line ends, and PD was reduced back in line with the other two phases. The third example is of 11 kV 4-pole synchronous generator installed in 1980. Obviously, from the pattern and also the photographs, there is a visual indication of end winding discharge where the stress grading and corona shield has burnt. Here I end my presentation by saying PD monitoring helps to assess the insulation health of hydro generators, turbo generators, motors, and other rotating machines. Insulation failures are costly and it can be disastrous. So it's better that we avoid these insulation failures by start monitoring now. Thank you, and I'm happy to take your questions now.
Okay. Thank you, Rajendra. We have some question here in the Q&A.
Yes, please.
I already have sent you the translate in English. Can you see it in the direct message?
Yes.
Yes.
Looking at it.
Yeah, the first question is, does PD always happen at variable frequency drive motor only? We already use grounding ring, but the bearing still fail. What is the maximum value of bearing insulation to protect it from PD? So that's the first question from 𝗣𝗿𝗁𝗵𝗵𝗶.
The answer would be again like what we discussed of different effects on the generator or the motor. So it is teams. It's not only the variable frequency which is affecting the generator and motor, it's the mechanical forces, electrical forces as well, which acts on the motor. I hope that answers your question.
Yeah.
And the maximum value of bearing insulation to protect, I'm not sure of that. I really have to check on that.
We must check all the data, right?
Right, that's right.
Okay. But how about they already use grounding ring, but the bearings still fail?
So again, the cause of bearing insulation fails can be different from the windings of the generator or motor, which we are talking about.
Oh, okay. Okay, thank you.
It can be a completely different topic from us.
Okay. Okay.
Yeah.
Okay, the second question from Pak Fareja. The question is, in two different generator, base load generator and the peaker load generator. Which one do have more risk to PD?
Definitely the peak load ones.
The peaker, right?
So
Why?
it's running on the higher loads. It has more thermal stresses and more electrical stresses.
Okay. Thank you, Rajendra. And from the question from 𝗥𝗿𝗁𝗶𝗶 𝗂𝗏. Oops, sorry. What is the effect of the PD to the vibration, such as velocity or acceleration?
So from my experience, they do have some correlations. When the vibration increases, definitely it causes PD, as we discussed earlier. So PD is the outform of the vibration, but not from the partial discharge. It doesn't create vibration, but because of the vibration, partial discharge occurs.
Okay. And the other question from Pak Fareza. If we find clouding in partial discharge online measurement, what recommendation we must do to the generator?
So when we find a fault on the generator, just an example that it hits the thresholds or alarms of the partial discharge, the first thing we have to check is the pattern. So we have, depending on the partial discharge patterns, we can identify what type of fault it is. And different faults has different severities. So we don't have to act immediately, but we need to analyze what type of fault it is, how severe it is, and depending on that, we have to act.
Okay. We hope it is clear for all our customers. And I think that's the question, Rajendra. And from me, maybe you can give a suggestion for us, to our customer also, related to this pandemic situation, that some of our customers have a limit budget. Maybe from us, we have some solution for this. Before I go to the next question.
Yeah, I understand. This is a difficult situation for everybody.
Yeah.
So unfortunately, the machines doesn't know it.
Yes.
The machine doesn't understand what the pandemic is. It still does what it has to do, and we have to take care of them. So as we have limited budget, what I would suggest is we at least do the offline monitoring at the moment. So whenever you have a chance, you try to shut down your machine quickly and do the offline test. The even better thing is you at least install the partial discharge sensors. With that, you have the ability to do the PD measurements whenever you want. And the cost of doing partial discharge measurements online is very less when compared to the offline.
Yeah, agree. The condition monitoring must go on, yeah.
Yeah.
Yeah,
the life has to go on.
There is another question, Rajendra, from Pak Rian Gunawan. He has a problem with their turbine generator. The circuit always broken, even it just work only 40% from capacity. We do check from mechanical side regarding vibration issues. If there any other possibility with electrical issues, and if we do the PD method, is there can find the root cause.
So I didn't hear you properly. What did break?
The seal pin.
Seal pin.
Yes, I will copy you the question.
Yeah.
So the seal pin always broken. So join between generator and the box.
I'm not so familiar with this word share pin. I don't understand it. I'm sorry for that. Can you please elaborate that question, please?
Let me. Okay, so the question is.
So yeah, I got it. It's the coupling you're talking about, the generator and gearbox coupling.
Yeah.
Again,
yeah.
Yeah, I don't think partial discharge will be able to find these problems. This is more related to the mechanical dialyzers. It could be related to your load also. So I don't think monitoring partial discharge will help anything in this. I'm sorry for that.
Okay. Jadi Pak Rian Gunawan must check more detail in vibration issue, right?
Yeah, it could be a vibration issue, or it could be a load issue, uneven base issue. It could be anything.
Or another issue, yeah.
Yeah. So when we, again, just to clarify again, when we talk about partial discharge, it's more of the stator, generator or motor stator we are talking about.
Yeah. I think that's clear. And okay, I think that's all the questions from our participant today. Around 37 maximum I noticed from this morning, but register this morning register until 80. So that's maybe maybe in online webinar, so many unprediction time happen.
Yeah, I know.
Okay.
I know some of the participants might still be having some questions. Please feel free to drop me an email or drop an email to Mr. 𝗤𝗏𝗍𝗍. We'll try to come back to you and answer all your questions, as many as you can.
Oh yeah, another question.
Yeah.
Rajendra.
Yes.
If we use the PD monitoring, both in online or offline, can we find which part of the equipment that we can find using the PD monitoring?
Yes, it is always good you do the offline and online monitoring. So you need to understand the purpose of online monitoring first. Firstly, the purpose of online monitoring is to identify the faults while the machine is running. So when the machine is running, you don't have any other sensors installed on them. You don't know how the machine is acting. So online monitoring gives an indication what's wrong going on the machine. So when you start doing offline, it can prove you that whatever the online monitoring device has identified, it can show you that it's right, and it can prove you, and it can give you more confidence that the test is correct. You have to take the action on the machine. So yes, definitely you should be able to identify the weak spots by doing online and offline monitoring.
Yeah, okay, good answer, Rajendra. Thank you. I think all the answer is very clear to all our customers. And any message from you, Rajendra?
Yeah, I think we plan to do this webinars often from here. We'll try to do at least once in 2 months. So if your audience can give any suggestions, what topics they would like to hear and what are the issues they are facing, you can concentrate more on those topics from now on.
Okay, yeah. Thank you, Rajendra, for your presentation and discussion during this webinar. Hope this have a benefit for all our customers regarding to the PD monitoring. And like we discussed, the condition monitoring must go on even in the pandemic of PD, because our critical equipment or machine doesn't know it.
Yeah.
Okay, thank you again, Rajendra, for coming. See you on our next webinar.
Yeah. Thank you all the guests for joining today. Have a good day and please be safe. Take care of your families.
Yeah, have a good day, Rajendra. Stay safe and healthy. Thank you.
Bye, Roger.
Oke, Bapak Ibu, terima kasih atas kehadirannya ke webinar kali ini 1 jam, kurang lebih 1 jam. Semoga bermanfaat dan saya sampaikan terima kasih kembali. Tetap menjaga kesehatan, protokol kesehatan yang tepat, segera vaksin, dan salam sehat untuk semuanya. Terima kasih.